welcome to another calculus video. Today we're going to be talking about complex differentiation practice. This is just because all of the examples we've looked at so far are really pretty simple. So we're going to add on a few more steps and we're going to try and work through them in a more efficient manner because hopefully you should be used to the way that we're doing things now. So first we're going to talk about the repeated chain rule, which is just kind of a generalized form of something we need to do when we have so we know how to differentiate f of g of x, but what about f of g of h of x? So the way we're going to go about this is first we're going to call g of h of x k of x, right? So now we have f of k of x. So the derivative of this is going to be f prime of k of x times k prime of x. And k prime of x is going to be, so k prime of x equals g prime of h of x times h prime of x, right? That's just using the chain rule over and over. So the derivative of this is going to be equal to f prime of k of x, which is just g of h of x, times g prime of h of x times h prime of x. So if you notice this pattern here, we just take the derivative of the outer function times all the functions inside it, then the derivative of the next function down with all the functions inside it, then we just keep going down. And so as you see, when we start these problems, instead of identifying what f and g are, we're just going to start differentiating, and then we're going to just keep tacking on all the inside functions. So let's go into an example where we can look at that. So first we have differentiate 1 over square root 1 minus x squared. So first we always have to rewrite this when we have a power in the denominator. So this is going to be 1 minus x squared to the negative 1/2. So the way we're going to do this is we're just going to start differentiating. So we're going to bring this 1/2 to the front, negative 1/2 to the 1 minus x squared to the negative 3/2. So we brought the power to the front and we subtracted 1 from the power. Then let's think, okay, what was our inside function? So instead of identifying f and g of x at the beginning, we're just going to start doing things, and then we're going to think about what was on the inside after. So what was g of x? This was g of x, 1 minus x squared. So what's the derivative of that? Well, 1 is just 0, and minus x squared, that's going to be minus 2x. So this is going to cancel with that, and we're just going to have x over 1 minus x squared to the 3/2 power. So I moved through that kind of quickly, but that's something that we're going to have to learn to do, because when we get more and more complex problems, we don't want to be spending all our time just going through formalities. We can just start quickly identifying what's the derivative of the outside, what's the derivative of the inside, and just keep going like that. So this is our answer. Okay, now we have 1 over 1 plus sine of x squared. So again, we're going to do 1 plus sine of x squared to the negative first power. So again, we're just going to bring the power to the front. Negative 1 plus sine of x squared to the negative 2 power, because we just subtracted 1 from this power. Then what's the derivative of the inside? Well, we have sine of x squared, so that's going to be cosine of x squared. But wait, we still have another inside function that isn't just x. So now what's the derivative of x squared? It's going to be 2x. So now we multiply all of these together. We have negative 2x cosine of x squared over 1 plus sine of x squared squared. So again, I moved through that really quickly, but that's something we're going to have to start learning on doing. So here we had, as you can see, this is f prime of g of h of x. This is g prime of h of x, and this is h prime of x. I kind of moved through it really quickly because we just had to start differentiating and then thinking about, okay, once I differentiated that, what was on the inside that I need to now tack on the outside? So again, this is f prime of g of h, this is g prime of h, and this is just h prime. All right, now we have e to the x. So again, we're just going to start differentiating. What's the derivative of e to the x? Just e to the x. So we're going to recopy that. Then what's the derivative of this inside function, which is also e to the x? So we have e to the x. And if you want to, you can kind of combine these. So we're going to combine since we're multiplying, we can add the exponents together. So it's going to be e to the x plus x, and that's our answer. So this was just an f of g of x case, but still we kind of moved through it quickly, and we're going to keep seeing more and more of that. Okay, now this one, again, we're just going to start differentiating. So we have sine, we know we're going to have cosine of whatever's on the inside. And what's the derivative of this? Well, that's going to be 3x squared minus 4x. Again, we're just doing power rule, bring the power to the front, subtract the power by 1, plus 1. And so it's going to be 3x squared minus 4x plus 1 times cosine of x cubed minus 2x squared plus x. That's our answer. All right, 2 more problems. We're going to have ln, or natural logarithm of secant x plus tangent x. So the derivative of ln x is just 1 over x, so 1 over secant x plus tangent x times the derivative of secant x plus tangent x. So secant x, we're going to have secant x tangent x, and tangent x, we're just going to have secant squared x. And actually, if you see here, we can factor out, okay, actually I'm going to rewrite this really quickly. Secant x tangent x plus secant squared x, or secant x plus tangent x. This is going to be equal to secant x. We're just going to factor secant out of each of these. Tangent x plus secant x over secant x plus tangent x. These are going to cancel because of the same factor. So this is just going to be equal to secant x. So that's the derivative of this function. And last question here, we're going to have inverse sine of x minus 1 over 2. So derivative of inverse sine is 1 over square root 1 minus x squared. So 1 minus x minus 1 over 2. And the derivative of x minus 1/2. So this is x minus 1 over 2. This is going to be the same as x over 2 minus 1/2. So the derivative is just 1/2. So we're going to have 1 over 2 square root of 4 minus, oh sorry, this is squared here, 4 minus, x minus 1 squared, and then there's going to be an over 4 here, but we're going to factor that out. So this is just going to cancel with the 2. So our final answer is going to be 1 over square root 4 minus x minus 1 squared. And we could simplify that, but we're just going to leave it be for now. So that was our last question for today. We moved through this video pretty quickly, and it should be something that you're getting used to when you're differentiating something complex, to just start working and figure it out as you go along, because before you know it, you'll be an expert at this, and you'll just be able to grind through these problems and get them through quickly. Just important to remember your chain rule and all the fancy little rules that you can use to help yourself along your way. So I'll see you in the next video. Hope you found this helpful.